What's going on? Mr. Daab here. We're going to be talking today about another one of my foundational videos for excelling and exceeding in AP Physics, or really just physics too. Um, so we've talked so far. We've posted a video about algebraic manipulation, kind of the basics. I've posted a video about some of the trig remediation refresher, and this is going to be a review, maybe an intro, depending on who you are, of the guess method. The guess method is a method for solving problems. I'm sure some of you have used it in math or other classes before. But for 99% of you in AP Physics, this is the way to go. Okay. I know some of us don't like to write unnecessary information. I feel like some of us feel like it's a waste of time, but I am telling you, even after all of my experience and all of the problems that I have solved, this method will prevent you from making silly mistakes. It'll help you stay organized, and it'll help you um, organize your thoughts for writing a response for like a short answer as well. Okay, so I know a lot of us like to skip this method because it kind of feels like redundant, but I'll tell you, even my smarty kids, really smarty kids, right? They'll miss questions not because they don't know what they're doing, but because they get unorganized or lose their train of thought. And this method will help to prevent that from happening, right? So if you're someone who struggles with physics, the guess method is definitely a go-to because it organizes your thoughts and helps you move, kind of progress along in the problem-solving process. If you're an expert, it helps you to stay organized and just make sure you don't make silly mistakes, okay? So this method is super powerful if you use it right and if you know how to use it properly, okay? So I have an example here, and the point today is not to do kinematics. The point here is to see if we can set this up and find the best way to solve this problem. Okay, so the G in our givens stands for, the G in our guess method stands for givens, meaning anything that the problem has given us to take into consideration. Okay, so let's take a look. Generally, for most students, I'd recommend a quick read for the first pass, just to make sure that it's not a question with a whole bunch of useless information and then asks something like, what's the acceleration due to gravity, right? I know it sounds silly, but it does happen. You could get 2 paragraphs of text, and the last sentence of the second paragraph could be all you really need to know in order to answer the question. So my first tip is to read a quick read through just to see what the question's asking. Once you realize it's a little bit more complicated, then you're going to go back through and look for your given information. All right. Now, the first bit of given information in this problem, right, says Daab is driving his Daab 900 Aero, and he is currently stopped at a stoplight that has been red for what feels like 10 hours, right? So there's a lot of useless information here, as cool as it is that he has his own car brand, right? The 900 Aero means nothing, okay? But the part we want to pay attention to is this, right? He is currently stopped. This is part a lot of kids when they first start with physics will kind of get hung up on, right? Because it doesn't say starts from rest always, right? It says he is currently stopped at a stoplight, okay? So that would mean that in my given, right, that I am, let's see if we can keep this pretty enough here. All right. So we know that my initial, or V naught, or VI, whichever one you want to use, but my initial velocity is 0 meters per second. And that's because of that. He is currently stopped, right? That means that I am not moving initially. When we start this problem, we start before I speed and do all my stupidity with my nitrous, I'm initially stopped, right? So I have an initial speed of, or initial velocity of 0 meters per second. You can see that I'm at a red light that's been red for what feels like 10 hours. Well, Mr. Daab, no one cares what things feel like in physics, right? Yes, 10 hours is a time value, but it has no significance for our problem because it's a feeling. All right. Then we kind of go on to this run on here, noticing that no one's around and no police officers in sight. Daab floors it and sets off 2 canisters of nitrous. On top of the world and feeling good, Daab passes a speed control device, you know, the ones that mail you a ticket, and isn't able to brake before passing the speed detection device. All right, so this whole gobbledygook text here, all it's saying is that he doesn't slow down, right? It's saying that I'm unable to step on the brakes before I hit the speed detection device, and so therefore we can't assume that I've slowed down, and we can assume that I've just accelerated continuously the whole time, pedal to the metal, nothing else going on, right? So we're going to just kind of isn't able to brake. I'm just underlining that so I know, hey, I'm not stopping, there's no funny business going on, okay? Then it says, assuming Daab was driving for a total of 6 seconds, right? This is important. This is my time progressed, total time value, change in time, however you want to describe it, but it's 6 seconds. So I'm initially not moving, pedal to the metal, start accelerating, do that for 6 seconds until I pass the speed detection device, okay? Lastly, we can see, and assuming his Daab 900 Aero can accelerate at the marketed 15 meters per second squared, how fast will the speeding ticket say Daab is going, right? So now we know an acceleration that literally tells us accelerate at, right, 15 meters per second squared. And so I'm going to put my 15 meters per second squared right here. All right. So I was given an initial speed of 0 by saying currently stopped. I have a time progressed of 6 seconds because it says while he's driving for a total of 6 seconds, and then the marketed 15 meters per second squared. Those are all my givens. Now, a distractor here might have been if they said his car has a mass of 1,500 kilograms, right? It would be important for you to then know that the mass is not going to impact our answer here. And so I don't list it as a given, right? If you wanted to and it gave you that information, you could probably write here, right? If it had told you this, and then hopefully you'd get to the point later where you'd realize that this doesn't matter, right? But you could write, I would recommend writing it down if it's given, and then later determining if it's applicable information or not. Okay, so that's our givens, and now let's go to our unknowns next. All right, and so the unknowns, I always try to start with, keep it simple, always try to start with what are we trying, like what's the problem actually asking for? Like what is it, if I could just answer the question, what would it be, right? And so it's important for us to understand what it's asking for here, right? But if we were in some car, and once again, don't be jealous of my awesome drawing skills, I've had lots of practice, so. All right, but we had this stoplight here, right? I was initially not moving. Oh, 0 meters per second is what I was going for. And then let's say we have our speed detection device here, and 6 seconds passes between this, and I'm accelerating at 15 meters per second squared. Do I know how far? No, I don't, right? I do not know how far it is in that between the speed detection device and the stoplight. I could probably figure it out, but I do not know, right? So it's asking, what does this thing say, right? Which, if we start at 0, we accelerate for some time, and then we're going some speed here, right? For the sake of our problem, I think it's safe to assume that the answer we want, or the thing we're looking for, is the final velocity. That would answer the question, how fast will it say I was going, right? Now, another unknown here, and I'm only going to mention this is because sometimes students, when they're starting out, might not see the first thing, but they might be able to get something else, right? So we mentioned here that we don't know what the distance is, right? And depending on if we had enough information, right, we might be able to find out what the distance is, right? But we'll talk about that when we get to our equations. But right now, we're going to say that my two unknowns are A, the thing we're looking for, which is this, and then maybe as a bonus, we could find out how far. I don't know. We'll see. Okay. So now we've done our givens, we've written our unknowns, and so things will start to speed up as we go through this process. Next up is the equations portion. Okay. This is where we are looking for any equations on our equation sheet, right, that have all of the variables, or excuse me, in which we have all but one of the variables that we would need in order to solve. Okay, that'll make a little more sense here in a second. So, okay. So I'm going to first just start by writing down I'll just do 3 of the kinematics equations, right? Once again, the point of this is not kinematics, the point is setting this up. Okay, so I'm going to say we've got our first one, we've got our second one, and we've got our third one. All right, so those are the 3 big kinematics equations, okay? So my suggestion with kinematics equations, and really with any equation in physics, is we're always looking for an equation where we have all but one, right? So we want to, in this first equation, let's call it first kinematics equation, right? There are 1, 2, 3, 4. There are 4 total variables, okay? 4 variables. So in order to solve, I need 3, okay? And so we can look at the next problem, 1, 2, 3, 4 again. Okay, so that second chemistry equation also has 4 variables, which means I need 3 of them. All right, cool. And the third one is very special because we can see it's got 1, 2, the 2 velocities before and after, a acceleration and a displacement. So once again, it has 4 variables. But I want you to pay attention, specifically when you get to kinematics, that the third kinematics equation is the one that doesn't involve time. And so a lot of times when you don't have enough information or you're missing the time variable, the third kinematics equation could be the easiest one to use, okay? But so we can see there's a general pattern here. Do we have 3 of the 4 variables? If we do, we can solve, okay? So for students who feel really comfortable here, I'd say just use the one that's going to be the quickest and send you on your merry way. For my students who struggle, it's important to realize just solve for an unknown. It may not be final velocity. You may decide, hey, I don't know how to get final velocity, but I do know how to get delta x, right? And my advice to you is to do it. The more variables you have, right, then the more of these equations you're going to unlock, and the easier it will be to solve for other unknown things. So my advice is, if you get lost, just start solving for something that you can solve, and don't worry about the final answer. And it might become more clear to you as you start solving for some other unknowns, okay? So if we look at these equations, we're going to look and see, hey, let's look at this first equation. On this first equation, v, which is going to represent v final, do we have that? No, we do not, right? We do not have that. We want that, but we do not have it. Do we have the initial velocity, though? Yes, because initially I'm stopped at the stoplight, right? Do we have the acceleration? Well, yes, it says it's marketed at 15 meters per second squared. Do I have the time elapsed? Well, what do you know? It said 6 seconds of the total duration. So I can see here that my first kinematics equation, I have 3 of the variables, and 1 of them I do not have. And the one that I do not have is, in fact, the one that I wish to solve for. All right, so we got lucky here. It was just our first attempt, but my initial velocity is 0 meters per second. I have an acceleration of 15 meters per second squared, and I have a time elapsed of 6 seconds. So this equation, and by the way, this is me going into the substitute portion of my guess method, right? Where I can simply just come over here and say, okay, well, this should be about 90 meters per second, right? 6 times 15 would give me 90 meters per second, right? If it is, in fact, since it asks me how fast will the speeding ticket say I was going, well, then I can just put 90 meters per second, right? If it had said, what is the velocity vector of Mr. Daab's car at this point, then we got to make sure that we add that 90 meters per second rightward, right, or something eastward or something like that, right? But since it asks for just speed or how fast was he going, it's okay for us to not worry about this direction, right? All right, so you can see that that worked pretty well. We did our givens, we took down our givens, identified what our unknowns are, the things we want to find. We then listed out any applicable equations, and then we would check to see which variables we had in reference to those equations. And then in doing so, we found out, hey, we could use the first equation, right? But let's just assume that you had, say, I don't know why, but let's just say you picked the second equation first, right? So let's just say you picked that second equation, and you're like, okay, well, delta x equals v initial t plus 1/2 at squared. Okay, do I have delta x? I do not. Do I have the initial velocity? I do. Do I have the time? I do. Do I have a? I do. Do I have time again? I do. So here we have our variables, or enough variables to solve for an unknown. This wouldn't give us the final velocity, but it would give us something we don't have, which is distance. And so you could very easily then just say, well, 0 meters per second initially, right, times 6 seconds, which won't matter, plus 1/2 times 15 meters per second squared, which was my acceleration, times my 6 seconds squared. Okay, this will give me my displacement. All right, and so then if we plug this into a calculator, so what's that? 36 times 15. All right, we're not back in school yet, so my brain's still a little. 540 divided by 2, right? 270. sorry if this is wrong, kind of do this in my head here, but I'm going to say is equal to 270 meters. Okay. So if we had gone this way and we found that 270 meters, we still don't have that final velocity, right? But now those other two equations, I could use either to solve, right? So I could do that third equation, right, equals 0 squared plus 2 times 15 times 270. All right, and if you work this out, I'm not going to go all the way through this right now. I just wanted to show you guys that this is possible, right? And then don't forget you would have to root, right? You'd have to square root your whatchamacallit, the end value, right? That 270 times 15 times 2. Just make sure that you take the square root. So I'm going to make sure my square roots button's working. There we go. And we can see that it gives me 90. And that's a good way to check, right? Checks out because this and this are the same. All right. So the point of this, once again, was just to go over the guess method to show how to set up. It's not so much about solving the physics. Don't worry about if the actual equations don't make sense or some of that. The real point here is to start practicing from the beginning this method from the easy stuff, right? When we start in the very beginning, we do the easy stuff in physics, or excuse me, I shouldn't say easy, the easier stuff in physics. Start from right out of the gate doing this method, and then as things get harder, your life will be easy. Okay, so please do not abandon the guess method, which means givens, unknowns, equations, substitute, and solve. I promise it will be a game changer. Until next time, I hope you learned something.